In this video, I'm going to give you a sense of what the routing part of the project's all about. I'm assuming you've already looked at the code and read through the spec, but even if you haven't done that yet, you might find this video still helpful. But just be warned, that's the assumption I'm making in making this video. So I'll start by saying that this part of the project is going to feel a little messy and weird because we're working with a real data set. And when working with real data, things are often strange. In particular, we're going to be working with a data set from the OpenStreetMap project that basically has all the information you might need from a street map other than just the pictures. So for example, the file will contain where various intersections are. So it'll say like the intersection of Bancroft and let's say Telegraph is at this latitude and longitude, that kind of thing. That's within the data set. And so your job is to basically get all of those roads, edges, and all the intersections, nodes, into the system, and a little bit more if you decide to do the goal points. So in this format, right, there is a specification written up, and this is what you should at some point look at during this project. This is the description of how everything works. This is how we built the project from the specification, but I'll give kind of a quick overview rather than going through all the details. Okay. So in an OSM file, and in fact you have this file by the way, it's called berkeley.osm. This is the file that you're going to be using, so I'll just talk a little bit about its format. So in this format, these files always have the following information in this order, these 5 things. So what are those? Well, we look here and we see they always have an XML suffix, an OSM element containing and then a block of nodes, a block of ways, and a block of relations. Each of these things has a hyperlink, like this is what a node is, and this is what a way is. And I think it's a good exercise to do that, to actually look at this documentation, because I promise at some point you will do this, where there's some format that's decently, terribly, awesomely, who knows, documented, and you gotta look at it to figure out what's going on. And you won't have somebody doing a nice video like this, though in the environment at Berkeley where, we only have like a week and a half to build this thing and you have 3 other classes, I am gonna do a little bit of spoiling here. So anyway, you have these first 2 pieces, which we're not really gonna care about, and these will be the 2 we really care about. So I'll start by just showing you roughly comparing the file we have with what the spec says, right? And I can full screen this now. So if we look at the first line of this code, we see an XML version, and that is the XML suffix introducing this character encoding. We don't actually care about this. Next up, we have an OSM element containing the version of the API, so we don't care about that either. We're not writing an industrial strength application, so we'll ignore that as well. There's this, which is not actually listed in the OSM spec. I don't know why it's there. So this is where we finally start getting some information, which is our block of nodes. So these will be all of the vertices in our graph, though we won't keep all of them, but each of them represents just some point of interest. It could be an intersection, it could be the corner of some building, it could be the location of it doesn't have to be a road necessarily, it could be anything you want to annotate as existing in space, you would use a node for. And then we'll have a block of ways. Okay, so this is a block of nodes, and when I say a block of, I mean if you look at the file, you see node, 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 node. There's a lot of nodes, like lots of them, thousands, see? And some of the nodes actually have more information. And so what this says is this is not just a node, but someone has also noted this is a motorway junction. Many of these nodes have no description of what they are, but some of them do. And you can keep looking and you can find all this stuff. Like we'll look at more. This is, I don't know what PGS means. Let's see, JOSM, that's who created them. Sometimes people like to give themselves credit for having put stuff in the data set. Who knows? This is being constructed in early 2010. Okay, so it's an open data set, so there's going to be some cruft in there. But suffice it to say, that's what a node is. Okay. So then we have a block of edges in our graph, which are the block of ways. So if we scroll way down, I'm going to search for way ID. Okay, we've finished the block of nodes, and now we're in the block of ways. And what a wave represents is just a sequence of nodes that's somehow related in some interesting way. And so if we click on this documentation in the OpenStreetMap dataset, we can see that, okay, well, a way, it's an ordered list of nodes, and it can have a bunch of different nodes in it, and ways could mean different things, right? So it could be, for example, a street. It could be an area. Like, for example, I want to show the perimeter of a park. So in that case, you would have node, 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 node. That's the park. So ways can actually be a few different things, but we're going to be chiefly concerned with road versions of ways. Okay, so this is what a way looks like. We start with this way tag, then we have a bunch of nodes, and then a bunch of information about this. So this is saying the name of this way is Bancroft Way. It has a max speed of 25. It's in the county Alameda, and so forth. And some of this information we'll care about, and some we won't. And so this information here, this is extra, I call this extra meta information, right? Can you ride bicycles on this street? Yes. And so all the information may be useful. Now we're writing a mapping application, and so it might seem like the one-way tag is important, but because of the fact that this data set has bad one-way tags, we just decided not to use them. So you should not take into account this one-way tag. Don't do it, right? So that's in the spec, but I'm also repeating it here. Ignore one-way, okay? So there's a lot more you could learn about ways, but that's the basic picture, and this documentation will give you more if you want more information. So as far as ways go, I'll make a couple notes here, which is this max speed. The skeleton code, and I'll talk a little bit about that soon, it does mention how to keep track of the max speed, and that's if you want to try and play around with the max speed and develop a version of the routing software or the routing functions that will actually take into account speed limits. Because the way that our system, we're going to ignore speed limits, right? So we're just going to take the shortest distance as opposed to the shortest time. But if you wanted to, you could play around with speed. Now to pass the autograder, of course, you have to do what we did. But we're just mentioning how in the skeleton code to collect max speed if you want. Another thing is that the names of these nodes and ways, for that matter, so this way is named Bancroft. That is not useful unless you're doing the autocomplete part of the project. That's gold points. And so if you want, you can, when you first do this, store only the information needed for routing. So feel free to ignore the name. And then if you find you have the time and inclination to do gold points, you can then modify your graph building software to keep that information, okay? Now I just want to mention that this OSM file has tons and tons of information. You could do whatever you want with it. I mean, if you want, you can store the counties of everything, but we don't require that. We won't check it. But if you want, you're welcome to collect all the information and do like the completionist version of reading in the data set. So I should mention an important thing, which is in the spec, you're only supposed to store in the graph ways which correspond to roads. In other words, we call those valid ways. So there's a funny thing about the OpenStreetMap dataset, which is that they consider, let's see, do we have, I don't have an easy way to get to the highway, well, let's do it, OSM XML highway tag. Okay, there we go. So some ways are called highways, okay? So highway, usually, colloquially in English, it refers to a large road with like cars on it. But in the OSM dataset, highway is actually used for any kind of road, street, or even path. So if we go down to the highways, we'll see that it includes pedestrian paths, tracks, escapes, whatever those are. And so just keep that in mind that when we say highway, we actually mean like any kind of path, okay? It's one of those things where you set up a standard and then the standard outgrows its original intention, and then now we have to like hack the system to work. Gotta deal with it. Okay. So we'll say that a way is valid if it is a highway and it's one of the allowed highway types. So for example, let's look at this Bancroft example on the earlier slide. It is a highway and it's considered a secondary. Is secondary allowed? Okay, well, in the skeleton code, which I guess I'll pop open here, if we look at this as the code, I'll talk more about this in a bit, but in this code we see there are some allowed highway types, and indeed one of them is secondary. So this way here would be considered valid because it is a secondary, okay? And so if a given way is not one of those types, right, say it's a path, it should not be added to the graph because we're trying to do driving directions. So you shouldn't be driving down like trails. It's just not cool. You can drive down one-way roads the wrong way in our application, that's fine, but not where pedestrians go. That's just not polite, okay? So again, to remind you, or just because it's on the slide, this line is just saying, hey, highways used for all kinds of stuff, even footpaths. Now I also want to mention that some ways are not highways. Some of them are actually, for example, the perimeters of parks or say buildings or whatever else. So I'll just show you one real quick in the file. If we search for 2322 6440, here's a way which actually corresponds to the perimeter of Berkeley Bowl. It is not even a highway. In fact, this tag here says it's a building, so it's the perimeter of a building. So you should not include this in your graph because you don't want to be driving in a circle around the perimeter of Berkeley Bowl for some reason, right? That's not okay. Again, just not a thing we like. All right. So that's a conceptual picture of what routing is all about. I guess for the sake of conciseness, I'll actually cut this video here, and then in the next video I'll give you some tips about coding this thing up.